Hi everyone. Today we're going to be talking about lesson 10-10, which is graphing tangent. So if you look below, the graphs of sine x and cosine x are graphed. So let's just notate which one is which. So if we were looking at these graphs, how about we highlight the sine graph in yellow? So if I'm looking at sine x, remember sine starts at the midline, goes to the max, and continues from there. Whoops. Let's try that again. So midline, max, midline, min, midline. And we can trace it backwards. So here's my sine curve, y equals sine x. I also want to find my cosine curve. So y equals cosine x, starting at the max, then midline min, midline max. And again, I can trace it backwards. Okay. So I would like you to pause the video and circle the values of x on the graph where cosine equals 0. Okay, so we're looking at the cosine curve. So we're looking at the red curve that I just highlighted on the screen, and you want to find where the cosine of x is equal to 0. So I'm going to highlight those values in blue on the screen. Now remember, the tangent is equal to sine x over cosine x. So when we're thinking about tangent, if we know at these values that cosine is equal to 0, what do you think would happen if you try to find, let's say, the tangent of 90 degrees or pi over 2 radians? Here, if I were looking at this, the sine of 90 degrees would be 1, but the cosine of 90 degrees would be 0. So you can't take a number and divide it by 0. You get an undefined value. So this is just an example of what would be true for tangent at all of the values of x that are notated in blue. So tan x would equal sine of x over 0 for all of these x values notated in blue. 90 degrees, 270 degrees. If I worked backwards, I would say negative 90 degrees and also negative 270 degrees. I'd like you to draw a dashed vertical line at each of these x values where tangent would be undefined. Okay, so let's take a look at part D. Use your calculator to complete the following table and round each value to the nearest tenth. So pause the video and complete the table of values. Okay, so let's fill in our table. So the y values that you should have calculated were 0, 1. At an x value of negative 270, if you tried to type that in, remember, there's a vertical asymptote there, so that would have given you an error on your calculator, which means that the tangent is undefined there. The same thing would have happened at negative 90 degrees. You would have gotten an error, which means undefined. Okay, So now we want to sketch the graph of tangent based on the table that we just drew. So let's choose another color here. How about we use orange? So we want to sketch this graph, y equals tan x. So at negative 360, that's really negative 2 pi, if we're talking about radians. My tangent of x value is 0, so I'm going to plot that point here. Then at negative 315, that's going to be somewhere in between negative 3 pi over 2 and negative 2 pi. My tangent value is a 1. Negative 270, we said it's undefined. You can see that vertical asymptote there. At negative 225, which is somewhere in between negative pi and negative 3 pi over 2, it's going to be negative 1. Negative 180, 0. Negative 135, it's going to be a 1. Negative 45, it's going to be a negative 1. 0, 0. 45, 1. 135, negative 1. 180, 0. 225, 1. 270, undefined. Negative 315, negative 1. And 360, 0. Now, if you push graph on your calculator, you can see the general shape of the curve. So this is just going to be one part of the tangent curve. It looks like that. And then here on between negative 270 and negative 90, the curve is going to look something like this. And here again, I only see part of my curve. Part F asks what's the period of tangent. So what that means is how long does it take to go through one complete cycle. So if you look up here at the graph, I'm going to look right here at negative 90, over here at 90 degrees. If I look at the orange part of the curve, I see that there's one tangent cycle between negative 90 and 90. So this length between negative 90 degrees and 90 degrees is really an 180 degree interval. In radians, that would be represented by pi. So the period of tangent is pi. So again, period is the time it takes to go through one tangent cycle. And we said looking at the graph, we were looking from negative pi over 2 to pi over 2. Which is an interval of pi radians. Tangent doesn't have an amplitude since the range is all real numbers. So if you look at your graph of tangent, tangent extends infinitely down as well as infinitely up. So when asked about the amplitude, we just say none. Okay. So next there's a little summary page about tangent. One cycle occurs every between negative pi over 2. It's a little hard to see that negative there. And pi over 2. So if I were looking at my graph, here's my asymptote at negative pi over 2 where tangent is undefined, and my asymptote at pi over 2. And I see one complete tangent cycle that's graphed in red between them. There are vertical asymptotes at the end of each cycle. So every pi over 2, at pi over 2, there's an asymptote, and every pi units, there's going to be another asymptote. So if I'm at pi over 2 here, right, there's my vertical asymptote, at another 180 degree interval, or pi units, I should see another asymptote. So if I'm here at pi over 2, if I want another pi units or 180 degrees, I should see another asymptote here. We talked about the period being pi. because if you look between negative pi over 2 and pi over 2, you see one tangent curve, no amplitude. Tangent's an odd function because it has symmetry with respect to the origin. Please pause the video and answer the 3 practice questions. Let's take a look at practice question number 1. The correct answer should be choice 2, 90 degrees. Tangent is undefined at 90 degrees. If you go back up to your graph and you look at 90 degrees or pi over 2 radians, you can see there's a vertical asymptote there. So it would be undefined. If you typed into your calculator tan 90, it would give you an error, which means there's an undefined value there. Let's take a look at question number 2. Which of the following represents the period of tangent? So that means how long does it take to go through a complete cycle? The correct answer here would be pi radians. So if we look back up at our graph to go through one complete cycle, I'm going to look from asymptote to asymptote. So there's an asymptote at negative pi over 2, and there's an asymptote at pi over 2. So you're looking to see what this interval is, which would be a 180 degree interval. In radians, that would be represented as pi radians. Okay, let's take a look at the last question. So as x increases from 0 to, just add this in here, that should say pi over 2. I want to know what the graph of y equals 2 tangent x looks like. So if you go to your calculator and you type in 2 tan x, I want you to take a look at it. So we're only concerned about what the graph looks like from 0 to pi over 2. So if you look at your calculator, your graph should look something like that. So as x goes from 0 to pi over 2, your graph is going to increase without limit.